So if we start with a problem like this, how is this different from the problems we've done in the last couple days? Has an equal sign. That's the major difference. Okay? Now, this one is going to be a little bit different than the way we do other ones, but I definitely wanted to show you an example of this. Because you can actually do this one the way we're going to do other ones, but there's also a shorter way to do this one. Do you know how to solve an equation with two fractions set equal to each other?
Yes.
How? Cross multiply. Okay? I cross multiply there and cross multiply there, right? So I would get 4 times x plus 6 equals 5 times 2x, right? That's what it means to cross multiply. Do you agree with that? Okay, so what do I get on the left-hand side of the equal sign? Plus 24, good. And what do I get on the right-hand side of the equal sign? 10x. Is that a problem you know how to solve? Like really easily, right? You've been doing that problem, you've been doing these kind of problems for years and years, right? So if I subtract 4x from both sides, I would get 24 equals 6x. Last step would be, good, divide by 6. So x equals what? 4. Is that the right answer? Are you positive it's the right answer? How could you be positive? Plug it in, right? So 4 over 8, right, equals 5 over 10. So I substituted a 4 in anywhere there was an x, right? Does 4 over 8 equals 5 over 10? Are you positive? They both equal 1/2. So does 1/2 equal 1/2? Yes, so I know without a doubt that 4 is the correct answer to this problem. Okay? So I wanted to show you one cross multiplication problem because there are some cross multiplication problems in your homework. How do you tell if you can cross multiply to solve? One fraction set equal to one fraction. Okay? Most of the problems in your homework look like this, though. Is this one fraction set equal to another fraction? No. So we have to know a different way to do it. Okay? Now, last couple days we've been talking about getting a common denominator, right? We still want to do that today, but today is more fun because today we're actually going to use that denominator to eliminate the denominator. We're like a denominator assassin. Okay? That's what we get to be today. All right? So looking at these terms right here, if it was just 3 and 6, what would our common denominator be? 6, right? That's pretty easy to think about, right? Well, what if it's 6 and 3x? What is our common denominator? 6x. That's very correct, okay? It's not going to be smaller than some of the denominators. Remember that? We talked about that yesterday. It has to be at least as big as the biggest one and maybe even bigger, okay? But it's not going to be smaller than any of them. So I've got a 3x and a 6, so I know my common denominator is going to be 6x. Well, how does that change when I have this denominator? Or does it change at all? No, it doesn't, does it? Because I already have a 3x and a 3x. Is my common denominator still 6x? So here's the difference. Okay? We already talked about the fact that this is different to begin with because it has an equal sign. Because we're trying to solve for x. When we're trying to solve for x, we don't want fractions. Wouldn't you rather work with an equation with no fractions in it as opposed to one with fractions? Okay, so we're going to eliminate the denominator. But we found the denominator, we found the common denominator for a good reason. Because that's what we're going to use to eliminate the denominators. Okay? What did you say the common denominator was? 6x. So I'm going to multiply this entire problem by 6x. So what it actually looks like is I actually have 2 over 3x plus 1 over 6 equals 4 over 3x. If I multiply every single term by 6x, if I distribute that to every single term, doesn't it look like this? Is that a better way to look at it? Yeah, here you might remember the first one and the second one, maybe you'll forget the third one. So maybe just multiply every term by 6x. Whatever that common denominator is, multiply every term by it. And then watch the amazing things that happen. God bless you. Look at this x and this x. Am I allowed to simplify those x's to 1? Am I allowed or no? Yes, because they are factors. Yeah, that's right. Okay. What else am I allowed to do? Yeah, absolutely. I can simplify the 3 and the 6 to be a 2 over 1, right? So just looking at this first term, we haven't even gone on yet, just looking at this first term, what's left? I have that 2 and I have that 2. So what's left? 4. Now just look at the middle term. The second term right here, what am I allowed to do? Simplify the 6's, right? So what's left? X. 1x or just x, right? Okay. And what about the last term? Oh, I got equals, right? Got my equals. Don't forget that. What about the last term? What am I allowed to do? You sure can. Simplify the x's. 1 and 2. So what does it equal? Excuse me. Yeah. Geez, guys, this equation is equivalent to this equation. Which one of these two would you rather solve? Yeah, the bottom one, right? Excuse me. What's left to do to solve this equation? Yeah, most of you can even do that in your head, can't you? Excuse me. Yikes. Let me get some water. Is it the right answer? Should we check? I mean, really, is that really important? Yes, okay. We're going to go all the way back to the top. We don't want to go here because we could have made a mistake here. Let's go all the way back to the top, okay? So 2 over 12, right? Plus 1 over 6 equals 4 over 12. Well, in order to figure this out, I need a common denominator, don't I? Wouldn't 12 be a good one? So 1 over 6 becomes what? 2 over 12. So 2 over 12 plus 2 over 12 equals 4 over 12. That's right. So is this. Any questions so far? Okay. So what about this one? First thing we have to do is what? Find a common denominator. Find common denominator. In this case, what is our common denominator? How did we think through this yesterday? What is this denominator? X minus 3, right? Is it a factor? Can I factor it is what I meant to say. Sorry. I can't factor it, right? That's the lowest it can go, okay? Can I factor it? No. Can I factor this? No. Okay, so this is one factor, this is one factor, and this is one factor. Is there any that they share? Any factors that they share? An x. So that for sure is going to be part of the common denominator, right? Are there any other factors that are there? What about this one? Isn't that a factor? Isn't that a different number than x minus 3? Now people are confused today because they know this one has an x. That doesn't mean it's a factor. Okay? this is a different number completely than this one, so that is also a factor that we have to have in our common denominator. So x times x minus 3 is what our common denominator is. Does that make sense? Two of you? Excellent. Okay. So what do I do with that common denominator? Multiply to each term, right? This is where we get to be the denominator assassin. You better watch out. X times x minus 3. X times x minus 3. X times x minus 3. So just look at this first term. What happens? X minus 3's eliminate, right? They simplify to 1. And what do I have left? 2x. What happens to this middle term? Can you tell me which x's you're talking about? Like this one? Okay, this one. Can I cancel it with this one?
No.
Why? It's part of the number. Very good. That makes me happy. What's left? So x minus 3, right? So plus x minus 3 equals what? Very good. And what's left? Oh, you guys are making me laugh. If I distribute that,
X squared.
thank you, x squared minus x. Right? Okay. Now what? Combine your like terms, right? So here I've got 3x minus 3 equals x squared minus x. What kind of problem is this now? Starts with a Q. Oh, quadratic. I know that was probably too much of a hint, but okay. If it's a quadratic, what do I need to set it equal to? 0, okay? So I need to move the 3x, and I need to add the 3. So I get 0 equals x squared minus 4x plus 3. Oh, I forgot step 3. What was step 3 after we multiplied by each term? Solve. Okay, we're here. What do I do now? Yeah, factor. What is this factored? -1 and -3. So what does x equal? Good. 1 and 3. Are they both right? Positive? Well, okay, so you want to be even extra positive, so we would check, right? Okay. So 2 over 1 minus 3 is -2, right? Plus 1 over 1 equals 1 minus 1? 0 over -2? Wait, is that allowed? Yeah, we can have 0 divided by a number. What does that equal? 0. So I have -1 plus 1 equals 0. Is that true? That is a solution. Okay, 3. 2 over... Uh-oh. 2 over 0? Can I divide by 0? What does that tell me about this? It's not a solution. So it's really good that we were extra positive, right, this time? Because it turns out that this is a solution that we got when we solved the equation, but it turns out to be something called an extraneous solution. It's extra. It doesn't work. Not that kind of extra, but the math extra. Okay? Questions? How are you feeling about this so far? Good? Awesome. Okay. So here's the next problem. X plus 3 over x minus 3 plus x over x minus 5 equals x plus 5 over x minus 5. So first step, find a common denominator. What's going to be our common denominator for this problem? X minus 3 times x minus 5. That is correct. Anybody have any questions where she got that from? Maybe you didn't see it right away at first, but after she said it, does it make sense? Yes? Okay. So if I multiply every problem by x minus 3, x minus 5, not every problem, but every part of it, x minus 3 times x minus 5, x minus 3 times x minus 5. So what happens? Wait, I can't just cancel these x's? Okay, good. Now, just so you guys know, on this problem, I'm not going to skip any steps because there's a lot of them. And I don't want to get lost. And I don't want you to get lost. So I'm going to just go ahead and write down what we have left. Are you agree with me that that's what we have left on this first part? Okay. What happens in the second part? Okay, x minus 5 simplify to 1. What do we have left? X times x minus 3. You okay with that? Okay, what about the last part? X minus 5 simplify to 1. And what are we left with? X plus 5, x minus 3. Got it? Now, even though this is long, is it easier than fractions? Yeah, so let's take our time on this one, figure it all out, okay? So I'm going to go ahead and distribute this to solve just this first part. I'm going to have x squared minus 5x plus 3x minus 15. Are you in agreement with me that that's what we get on this first part? Okay, now I'm going to do the second part. Very good. Very good. Okay. And then the last part. X squared minus 3x plus 5x minus 15. Now this is still probably stuff we can do in our sleep, right? Okay, so let's combine our like terms. I've got an x squared, which gives me 2x squared. I've got a negative 5x, a 3x, which gives me negative 2x, right? And then a negative 3x, which gives me negative 5x. And then I've got this one, minus 15. Now, be careful you know where your equal sign is, because I don't need to worry about anything on this side yet, do I? Not until I simplify this one side. Okay? Now let's go ahead and simplify this other side. All I have are these two x terms. So I have x squared plus 2x minus 15. Now, what kind of equation is this? It's quadratic, so how do we need to solve it? Set it equal to 0. So what do you want to do first? Probably we want to have a positive x squared term. Remember how I like to do that? So let's move everything to this side then, right? So subtract x squared, subtract 2x, and add 15. So what's left? X. Good. Oh, that's 0. Yeah, you're right. That's 0. Okay. So that's all I have left, set equal to 0. How do I solve that? Factor it, right? Now, it's not a trinomial, so I'm not going to get two binomials, something like this. But don't they have the common term? Take it out. What is it? An x? If I factor out an x, what do I have left? X minus 7. And that equals 0. So what has to be true about one or the other or both of these? Yeah, it has to equal 0. Okay, so we set them both equal to 0. Well, there's that one, right? And there's that one. Am I done? No. We want to check. Okay? So if I put in a 0, let me come back up here and put in a 0. 3 over negative 3 plus 0 over negative 5, so that's just 0, right? Equals 5 over negative 5. That would be negative 1, right? So negative 1 equals negative 1? Yes, it does. So does 0 work? Yes, it does. Okay, what about 7? All right, let's see. 7 plus 3 is 10. 7 minus 3 is 4. Plus 10 over 10 minus 5. Oh, sorry, 7. Why did I put 10? Sorry about that. 7 minus 5 is 2. Equals 7 plus 5 is 12. 7 minus 5 is 2. Well, can't I simplify this to something? 5 over 2, right? So does 5 over 2 plus 7 over 2 equal 12 over 2? So what does that mean? 7 works. Was that long? A bit. It was the longest example I did for you, right? Does that mean it's hard? Was anything that we did in here hard? No. The hardest thing most people find is figuring out what the common denominator is. Okay? So that's why we kind of did what we did yesterday in finding a common denominator. But then we multiply everything by that common denominator to be denominator assassins, right? Eliminate the denominator. And then we just solved this. It just took us a lot of steps because it was real involved. But we still definitely got the right answer, didn't we? Okay? Do you have any questions about this? Okay? You have a little bit of time here at the end of class to sit and work on your homework. So why don't you go ahead and do that?